Hey kids, welcome to another math video. This is for Eureka Math, grade 5, module 2, lesson 24 homework. And the objective here in this lesson is to divide decimal dividends by multiples of 10. Thankfully, they start you off easy because this is just like in module 1, and in my problem set video I talk about this and I show you how to do it. So if you don't know what you're doing here, please go watch the problem set video. I'll teach you all how to do it. This is hopefully your completed homework page, and we're just going to check it and make sure you can reason about the placement of the decimal point and make connections to this written method. The standard algorithm, eventually we'll get there. But for now, we're just going to be taking these apart into two pieces because you can do that when you divide by multiples of 10. So we're going to show every other division sentence in 2 steps. That means all of these are going to be the 2 steps. First 2 have been done for you, so we can start on C. Okay, so when we have our 2.4, as the kids like to say, I might say 24 tenths because I like to kind of move that decimal out. And if I'm dividing by 8 ones, then it makes it very easy to see what the answer will be. So I know it's going to be 3, but the place value positioning, the reasoning of the decimal is when you use that unit form, tenths divided by ones would be tenths. So where do I put the decimal? I put it here. So your standard form answer is going to be a 0.3 instead of 3 or a 3 elsewhere, like here. It's not just 3 ones, it's 3 tenths. Okay, now you can write that here if you want. You don't have to. In fact, you don't have to do any of that, but this can really help you make sense of it before you go into the multi-step or 2-step problem. Now, in my other video, I do show you that there are lots of equal signs here, and so we've got to do a couple of things. So you're going to take your 24 tenths. First of all, notice about the size of the dividend is the same, but our divisor is 10 times greater, so 80 is bigger. If I'm going to cut 2.4 into 10 times more pieces, then my answer should be 10 times less. Okay, so my reasoning is that if I have to split this into 10 times more pieces, then the size of each piece will be 10 times less. Now, the answer, if it's 10 times less, is to move the 3 over a place value position from tenths to hundredths. So why do I do that? Well, because I'm going to take my 2.4, just like we do up here. So I'm going to take the 2.4, copy it, first divide by the digit with value, then divide by the additional 10. Okay, so you're making it a 2-step. This is the first part right here. This answer, the 2.4 divided by 8, we already did that over here, 2.4 divided by 8. We already know that's 0.3 or 3 tenths. But the second step is to divide by 10. And so when you do that, that's when you have to know to bump the 3 from the tenths over to the hundredths place, and that's how you get your answer. Okay, so that's basically what we're doing here. Try to keep up. Hopefully you guys did your work already and you're not just copying, but you know what? If there was ever going to be one to copy, this would be it, because this one's kind of hard. Okay, so 14.6 divided by 2, you can either say it in chunks, like by ones. So if I said 14 ones divided by 2, that would give me 7 ones. And then if I had 6 tenths divided by 2, that would give me 3 tenths. So if you notice, that creates your number, 7 and 3 tenths, or 7 ones, 3 tenths, so 7.3. So anyway, lots of different ways to kind of put these together. If you can take them apart and then divide each piece by your divisor evenly without any leftovers, without skipping place value positions, you can do it. On this side, you're going to take a look. It's still 14.6. And instead of dividing by 20, you divide by 2, then divide by 10. 14.6 divided by 2, we already know the answer to that, and that is the 7.3. And then you still have to divide that, don't forget, by 10. So we're dividing it, so shifting the digits to the right, which gives you 73 hundredths. Okay, next one, 8 tenths. It's kind of like the first one, divided by 4 ones. And so you know it's 2, but 10th. Oops, my bad. 2 tenths. 2 tenths. There we go. In the right places. Okay, now both of these are changed. Look at our dividend is different, and so is the divisor. So when you think about what should you get, it's going to be a little bit harder. Well, it's like, well, this is not just 10 times more, it's 100 times more. And our divisor is 100 times greater as well. So if this is 100 times greater and this is 100 times greater, I'm very curious. What do you think is going to happen? Take your 80. Divide by your single digit. Then divide by what's left. Now with this one, we've got our 20. And then you still divide by 100. So I'm shifting to smaller place value positions not once, but twice, which gives me 2 tenths. Now notice that when you increase the size, we increased the size of both parts in an equal amount. So the 8 was tenths, now it's tens. So that went 1, 2. This was ones and it went to hundreds. That's 1, 2. A shift of 2 positions for both, it offsets. There's no difference in the answer. Okay? So I know you guys probably don't get that, but anyway, at some point, someday, maybe you do. Maybe you're like, oh my gosh, I get this. It's totally easy. Okay, 56 hundredths divided by 7 ones. And here's your 8, but what value? It's going to be hundredths because it's hundredths divided by ones is hundredths. And just standardize it, put the 0 in the ones place. Next one is 56 hundredths, same. Got to set it up in our 2 steps. Divided by 7, divided by only 1 0, so 10. Some people are still probably confused. This is 2 zeros, so it's 100. This is 1 0, so it's 10. If I have 56 hundredths divided by 7, that's what I had here, so I know the answer is 8 hundredths, but I then have to divide by 10 again. So that's going to be shifting to an even smaller position. That'll put me in the thousandths. There you go. Sorry, that is a 0, not a 6. Okay, and then finally, last row. So we have 945 hundredths, but you could break this again, noticing where if you can break it into pieces, but I have to caution you, if you have, say, 945 hundredths with your unit form divided by 9 ones, okay, now if you were to use the standard algorithm, you would see what's happening with the place value positions. If you don't, then you might make a little mistake here. So watch, I'm going to show you. If I divide 9 by 9, I get 1. But if I divide 45 by 9, I have 5. But I don't have anything in the 4s, and I do have something right here. I should say 10s under the 4. This one is like a 9 divided by 9 for here. The 4 divided by 9 is not divisible, and then it's 45 that's been regrouped. If I put it in standard form, you'll see what I'm talking about. This is what's happening, and the 4 comes down. Now when the 4 comes down, this has to go up and hold that place. That's why you have a 0 there. Some kids will go 1, oh, and 5, and they'll put 15 instead of the 0, and that's going to be wrong. Okay, so if it's hundredths divided by ones, the answer is hundredths. And if it's 105 hundredths, this is where your decimal was, and so that's your standard form. I really just prefer doing standard form. I don't like trying to do it this way because I think it throws too many people off. Anyway, that's just my opinion. Okay, 9.45 divided by a divisor that is 100 times greater. This is the same dividend. The divisor is 100 times greater. Your quotient then should be 100 times smaller, or 1/100th of what we originally had. If it's 1/100th of what we originally had and we only had 1, then that has to shift not once but twice. So your answer should be 0.0105. So I remember at the beginning of the year, kids said, oh, are we going to get out further than the 1,000th place? Yes, this is one of those times. Okay, so you take your 9.45, divide by 9, then divide by 100. This is where you get your 9.45 divided by 9. Then you divide by 100. And that's the shift right there. Okay? Now, on the next page, you're using place value reasoning and the first quotient, because they're giving you basically, look at the connection. You first quotient to compute the second. So no surprise, this is going to be the answer for this one. Same types of numbers, we're just off a little bit, okay? So reasoning like I did on the previous page, if this is the answer, okay, but my second problem, 65.6 again, my divisor is what I would say 10 times less, which is actually 1/10 of, then my quotient should be 10 times greater. Okay, so if the size of the pieces if the size of the divisor is less, then your answer would be bigger. So shift it one place value position for this 1, 0. And then write out your explanation. I'll say it one more time. Okay, the second divisor is, it's 1/10 of the first. Okay, and you might be more comfortable with 10 times smaller. So the quotient, this is important, the quotient is the answer, it will be 10 times bigger or greater than the original. And so then when you understand this, you don't have to actually do all the calculations. So that's a win, right? So 2.5, same dividend. Divisor. If our divisor is 1/10 the value, then the quotient should be 10 times bigger. So if this is 10 times bigger, it's going to move over from the 100th place to the 10th place. Okay, and it's the same explanation. Just write it again. The second divisor is 1/10 the first, so the quotient will be 10 times bigger. Okay, for C, look at your dividend, 19.2. It's the same. Look at your divisor. They're not even challenging you at this point. The divisor is 1/10 the value. It's the same. So what is the quotient? It's going to be 10 times bigger than the original. So we're going to shift it one place value position. Everything together, whoa-bum, and then 4.8. Copy. And at the bottom, don't get lazy, because you know they're going to throw something at you, and here they do. Okay. So here we have 39.6. That's the same. But here, they're flipping so that this first, okay, so the second divisor, division, divisor. The second divisor is what? Look out, it's 10 times greater than, my writing is so sloppy, oh my gosh, 10 times greater than the original. So if the divisor is greater, okay, I will have fewer. Then my quotient is going to get smaller. It's like their opposite relationship. So if the divisor is bigger, the quotient will be smaller. Will be or is 10 times smaller or 1/10 the original quotient. Okay, so we're going to shift this to smaller place value positions by a factor of 10 or one place value switch. So move the 6 in the ones place to the tenths and the other one follows. Okay, so I hope that reasoning is clear. I think there's like a test question at some point on the Eureka Math if you're getting tested on those. So be prepared to explain that. Okay, on the back. Chris rode his bike along the same route every day for 60 days. He logged that he had gone exactly 127.8 miles or 8/10 miles. How many miles did he bike each day? So this is all the days, and they want to know one day. Show your work to explain how you know. So what we're going to do is we're going to take all the miles that he traveled. She could be a she, Chris. He or she, he, there it is, 127.8. So he logged 127.8 miles in total, divided by the 60 days. Now this is starting to look a lot like what we just did. 127.8 divided by 6 divided by 10, first step here, second step there. So if you do break it into 2 steps, don't forget to do the second step. Sometimes when I do it this way, I forget that second step. That's why I prefer using the standard algorithm. And then do 127.8 to start, and then don't forget that step 2. This is pretty easy. Now that you kind of get used to it and kind of know what you're doing, 12 divided by 6 is 2. 2 times 6, use the division family. Subtract. This is nice when we have a 0. You can put Bob there. Okay, bring down the 7, divide. 1 time, use 6. We have 1 left over. Bring down your 8. And 18 divided by 6 is 3. Now that makes a 0. But what is that? That's step 1. That's this. But don't forget to divide by 10. So if you forgot to divide by 10, maybe you didn't get this far. It's going to be a shift of the digits to smaller place value positions by 1, or if you shift the decimal left 1 time, 2.13 miles each day. Now with that, go to B. How many miles did he bike over the course of 2 weeks? Well, how many days are in a week? 7, so 2 of them would be 14. So now you have a standard algorithm, multiplication 3 by 2 with a decimal. Remember that when we multiply with decimals, we ignore it. So I'm essentially thinking multiply by 100 to get it out and then divide by 100 to put it back in. So ignore it when you multiply. 4 times 3, 12. 4 times 1 is 4 plus 1 is 5. 4 times 2 is 8. Shift over because now I'm in the tens place, so 0 here if you want. 1 times 3, 1 times 1, 1 times 2. Add them up. And then divide by 100, ba-bam. And so in 2 weeks, he rode 29.82 miles in 2 weeks. If you can read it, you can write it. There you go. Okay, next one, last one. Oh yeah, click subscribe if you like the videos, if they're helping you, and come back and check in again. All right, 2 1/10 liters of coffee were equally distributed to 30 cups. How many milliliters, not liters, milliliters of coffee were in each cup? 2 schools of thought here. Divide by the 30 or change to milliliters immediately and then divide. So it's really up to you. You can do it either way. Both ways are correct. If you set it up like this and you divide the 2.1, you're going to end up with something that is technically like too small. So you have to kind of bump it over because 21/10 isn't big enough to be divided by 30. That's why it's a little bit easier if you want to take your 2.1 liters and say, well, gee, I don't know how many milliliters that is. Use your conversion formula that I taught you guys, 2.1 times the 1 liter times the 1 of the old and the equivalent of the new. 1 liter is 1,000 milliliters. And so you can change it right away. If you have to shift it 3 places or the digits to bigger, it's going to be 1, 2, 3. Now here you have something that's large enough to be divided by the 30 cups. And so now you can just start your division and everything is converted and you'll have the answer real quickly. So 3 does fit into 21, but we got to get it over here. This is where your digit would go for the first one. And we know that 7 times 3 is 21. So 7 times 0 is 0, and 7 times 3 is 21. 0, 0, 0, and your label. 70 milliliters per cup. Yay! All done. I hope this is helpful. I know these are super hard, so don't feel bad if you don't get it. It actually gets a lot easier in the modules to come. So don't fret. We will always have the standard algorithm to fall back on. All right, you guys have a great day, and we will see you on the next video. Bye for now.